Hello, everyone. My name is James Hartig, and I'm here to talk about scaling YugabyteDB effortlessly at Admiral. I'm a co-founder at Admiral, and just to kind of start off, I thought I would give a little bit of background on what Admiral does. We help publishers sustain online content through relationships. But what does that mean? Well, we help publishers by offering a platform that lets them offer subscriptions to their visitors. So if they have, let's just say, some unique content or premium content, they can offer subscriptions to make sure that only these premium users are able to access that content. In a similar vein, we can do a registration wall. And so if a user visits multiple times in the month, or maybe they're a high volume user, maybe you have to register after a certain amount of page views. Also, we can do engagements, asking visitors to like you on social or enter their email for a newsletter, that kind of stuff. And first-party data, that could be an email address, or it could be an interest, such as your favorite band or your favorite sports team. And then finally, we help publishers with privacy regulations such as GDPR and CCPA. I have some stats here. We're doing a little bit over 6,000 page views per second. That translates to roughly 16,000 gigabyte queries per second. And our engineering team is only a size of 8. In this day and age, publishers have to build relationships. With third-party cookies going away and traditional advertising going down in value, they need to store data about their users and collect first-party data in order to improve their revenue. So what different types of data can they store? They can store interests, whether the visitor likes fashion or a particular sports team, or whether they like certain news, or maybe even where they're located. And so you can give them targeted news. What subscriptions they have, and that could be Admiral subscriptions or even third-party subscriptions. If they're signed up for a newsletter, it's valuable to know what they're already signed up for, so you don't prompt them for that same newsletter, and maybe you want to prompt them for a follow-on newsletter or something. And then finally, their contact information. Maybe you have a print edition of your website that you want to send to the actual user if they pay a certain amount of money, so collecting that contact information is useful in that case. And you can use that to improve your revenue by personalizing your site. So making sure that you have the high value content at the top. If they like sports, for instance, showing the sports content at the top. Or if they like fashion, fashion at the top, or like a particular sports team, making sure that that sports team stuff is ranked highest on your page. Also entitlements, as I mentioned, subscriptions, making sure that they can only access the content that they're allowed to access. And you can actually change your content direction going forward. If you realize that all of these people are saying they like a certain amount of content, if you don't have a lot of content for that, maybe you want to add more of that going forward. And then finally, you can make direct advertising deals to sell direct advertising on your website based on these different interests that people have expressed. So a little bit about our tech stack. Admiral is powered by microservice architecture on Google Cloud. We have almost 100% Go backend, a little bit over 50 different microservices, and we're in 5 regions across 3 continents. So that would be North America, Europe, and Asia. At peak, we're doing over 13,000 HTTP requests per second, with just around 250 virtual machines. And our primary databases are YugabyteDB, obviously, MongoDB, and BigQuery. So we actually started using Yugabyte 2.5 years ago, and our first use case was for handling global accounts. And we needed single-digit millisecond reads from around the world. And I'll talk about that here. We're looking for less than 10 millisecond reads and less than 200 millisecond writes. The reason why we had a higher overhead on writes is those usually happen asynchronously in the background, storing what page views they visited or what type of content they like. That can all happen asynchronously. So the writes can take a little bit longer, but we needed horizontal scaling. If there's geopolitical events or even local political events, such as an election, we can see our traffic double from what's normal, just based on those things happening and the news sites that we have within our network. So we had to make sure we could easily scale, along with having minimal operational overhead. As I mentioned, our team is only 8 people. We can't have a whole person dedicated to maintaining this database. We have to make sure that we can just set it and forget it and only worry about dealing with it when we need to make any changes or upgrades. Since we're dealing with potentially sensitive data and personal information, we wanted to make sure there was encryption at rest and encryption at flight supported by the database itself. And once again, since our team is small, we don't want to have to juggle a ton of different technologies. Ideally, the database that we use could be flexible for other workloads, not just accounts. And since we have a Go backend it makes sense that we're looking for a driver that's written in Go and also maintained. So our solution, as you can imagine, was Yugabyte. It's a blazing fast CQL and SQL database. We were able to achieve single millisecond reads. We do that by having read replicas for low latency reads without affecting our write performance. So in the Europe and Asia continents, we have read replicas, so we can do writes that don't have to go across an ocean. It has automatic and transparent sharding for easy scaling. So we can add a new node in there, and Yugabyte will automatically move around the different partitions and handle that new node transparently without us having to worry about doing a bunch of manual work. It has a CQL and an SQL interface. So for things that don't require joins and things that we need to have very high performance, we can use the CQL interface. And for things that do require joins, and maybe as a smaller data set, we can use the SQL interface. And there's also cluster replication for different disaster scenarios if necessary. So how did we actually deploy YugabyteDB? So for this project 2 years ago, we ended up deploying it self-managed across 5 regions with a replication factor of 3. And so what that means is we have a primary in each of the 3 US regions. That's US West, US Central, and US East. And then we have 2 read replicas in each of Europe and Asia. And we're just using standard VMs with SSD persistent disks. And we're able to achieve 9,000 selects per second and less than 1,000 updates per second. So as you can see, this is a very read-heavy workload. And speaking of reads, we're able to achieve 4.5 millisecond select duration in the 90th percentile, which blew us away. We were extremely surprised. We were looking for something close to 10 or a little bit less than 10, and getting to half of that was just great. And we do backups using Yugabyte's built-in snapshot, and we upload those to GCS ourselves. Now, we started using it, as I mentioned, 2.5 years ago, and Yugabyte has seen some immense growth since then. There's been a lot of improvements to in-transit and at-rest encryption. They've added audit logging. They've added cross-cluster replication, which I already talked about, can be used for disaster recovery. There are snapshot backups, which we use, point-in-time recovery, and many under-the-hood query improvements that aren't even mentioned in Yugabyte's monthly blog posts. But a lot of things have also stayed the same. There's still an amazing, brilliant team. I think they're at over 300 people now. It's still a fast and reliable database. Even despite all these features being added, we haven't seen any change to the performance. We've had no issues with data loss or anything with scaling or anything like that. It's been extremely great for us. They have open source contributions, and along the same vein, they have a great commitment to the community. And on this free conference, it's a testament to that, as well as their weekly webinars and all the content that they produce and all the great documentation that they have to document all these features and make it easy to get on board and understand what's going on. So since we had such great success with Yugabyte for accounts, we decided, okay, what's the next big feature that we want to move over to Yugabyte? Where can we get a lot of value out of this database? And we decided the next thing was visitor events. So first, what are visitor events? So whenever a visitor visits one of our customers' websites, a publisher, we store all the different interactions that happen on that site. That could be a page view. It could be any engagements that they saw, what they did with those engagements, what they clicked on, whether they converted with the engagement or, like, for instance, entered their email or buying a subscription, or whether they bounced. Maybe they saw the engagement and left, or maybe they saw the engagement and immediately closed it. And they can use all those events to powerfully target different experiences for the user. So they can set frequency caps, once a day, multiple times a day, once an hour, once a year. You can imagine all the different possibilities of how they might want to target these engagements based just with frequency capping. They also can do progression. So maybe you want to ask the user to follow you on social first. And once they follow you on social, maybe you want to ask for their email. And if they've done both of those things, maybe you've decided that the next best step is offering a subscription to them. And maybe you think they're very likely to pay for a subscription if they've completed the other 2 steps. And finally, using the conversions and the bounce data, you can do A/B testing. So understanding exactly which engagements are performing better, which have higher conversions and lower bounces. Now, one difference from our accounts versus the visitor events is that our visitor events require strong consistency. We're okay on the account side with things being a little bit stale or a read not reading a write that just happened. But when it comes to visitor events, if you just saw a page view, we need to have that information immediately available for a read that might do targeting based on the experiences that that user have had already. And we determined that the best way to do that is to have an independent cluster per region. This allows us to do extremely fast core and reads that don't have to go to another region or doesn't have to cross an ocean, and extremely fast writes as well for the same reason. And so what happens is when a user visits one of our publishers, we lock that user to the closest cluster. And we have plans in the future to migrate visitors between clusters, say, for instance, if you're traveling or maybe you moved to a different state or a different country. But right now, we lock that visitor to that cluster and they stay with that cluster for the life of them. And we currently have 5 regions, as I mentioned, across 3 different continents, but we plan on growing that over time. So previously, we were using ClickHouse and Redis. Now, ClickHouse, if you're not familiar, is a column database, similar to Cassandra, but has some SQL components in it. It does replication, but via Zookeeper. And we had not previously used Zookeeper. So in addition to having to support ClickHouse, we also had to learn and maintain and support Zookeeper as well. And ClickHouse does merges behind the scenes. And so they don't support line rate inserts. So what we actually did is we used Google Cloud PubSub to batch inserts. So every single insert that we wanted to go into ClickHouse, we would send to PubSub. We had a separate consumer that would take a bunch of messages out of PubSub and insert them every few seconds. But we need strong consistency. So how can our inserts be asynchronous? Well, that's why we ended up having to put Redis in front of ClickHouse. So every single insert would go into Redis, as well as go into Google Cloud PubSub. And so then on the read path, we would always read from Redis first, and then fall back to reading from ClickHouse if there wasn't enough data in Redis, or maybe there wasn't any data at all for that user at Redis. So what did that look like in Redis? Well, we had sorted sets, 1 per user, which meant that we had to do manual trimming. Let's say that you're a user that visits every single hour, and you might accumulate a lot of data over time, or maybe you even visit once a minute because maybe you're a bot. Well, we need to make sure that the sorted set doesn't grow too big because Redis only clears out keys, not individual things inside of a sorted set. So we did some manual trimming there periodically to make sure that any user didn't have too big of a set. But we also had to adjust the size of our Redis instance over time to make sure that we were keeping enough data to withstand any ClickHouse outage or how long it takes to do batch inserts. So we had to manually monitor our key lifetime. But this solution was fast. Reading out of Redis, we had 5 millisecond reads in the 90th percentile and 5 millisecond writes. And 25% of the time we had to actually read from ClickHouse, and we were able to achieve 10 millisecond reads. And if you're familiar with ClickHouse, that was extremely impressive to us. ClickHouse is not made to do the real-time queries like that, but we were still able to get it to 10 milliseconds. And part of that was because we did a materialized view to automatically move the data over to a local SSD. But overall, this was a lot of moving parts and a lot of complexity. So some of our requirements for this project was that it needed to be at least as fast as our existing solution, ClickHouse plus Redis. So what that meant is we wanted to have less than 10 millisecond reads, and writes needed to be fast as well. Since they're synchronous, we had to make sure that writes weren't taking too long. So what we had a slightly higher goal there of 25 milliseconds. And it needed to be horizontally scalable, just like with accounts. We could have dramatic increases in traffic day to day, depending on what's happening in the world or what news events are going on. And ideally, it would also have built-in data expiration. So in ClickHouse, what we would do is partition the data by month, and then we would manually go in and delete months every once in a while to make sure that we weren't storing too much data unnecessarily. But it'd be nice if that was built into the database on a row level or even a value level basis, so we can just set that this row should expire after a certain amount of time. And if we want to update it, we can. If we don't want to, we don't need to. But also, since we have 5 regions and we expect that to grow in the future, we wanted to make sure that whatever we chose going forward allowed us to simply create clusters and easily maintain them. Additionally, just like with accounts, we wanted to make sure that any requirement that we or any database that we chose had encryption at rest and encryption in flight, since we could be dealing with sensitive data. And a tangential goal to this was reducing our costs and reducing our complexity. So we ended up choosing Yugabyte Cloud. It allows us to create clusters in minutes, and we're already familiar with Yugabyte, so there wasn't anything to learn. We already knew how Yugabyte worked. We were already confident that it could scale to the needs we wanted. And Yugabyte Cloud allows us to create and scale our clusters quickly and easily. So I can go in and make a cluster within a few minutes, or I can scale a cluster, whatever I want, all from within the Yugabyte Cloud interface. It also adds automatic upgrades, built-in backups, and monitoring alerting. But the biggest thing is we want to let Yugabyte manage Yugabyte. We know a lot about Yugabyte, but we're not Yugabyte experts. So a big thing that we get from Yugabyte, excuse me, is that they get to manage it, and they have the expertise, and we don't have to worry about it. So currently we have 5 clusters in Yugabyte Cloud with 3 nodes per cluster, but we're experimenting with 6, 9, and any more cluster sizes going forward. And the performance from Yugabyte Cloud has just been great. There's been no difference between Yugabyte Cloud and Yugabyte self-hosted, which we were originally concerned about. And part of that is because of VPC peering. So we can actually peer directly with Yugabyte Cloud to make sure that we're not leaving a region or anything like that to talk to the database. And we had 5 millisecond 90th percentile read or 90 percentile updates. Our 50th percentile on reads is actually 5 milliseconds. And the reason why I gave the 50th percentile number here is because we have some very large volume visitors that end up making the 90th percentile something like 30 milliseconds. And the reason being is that the 90th percentile rows that we end up reading is 800 for those big users. But the 50th percentile is only 75, much more reasonable. And that's why we're able to get to 5 milliseconds. And we're doing almost 5,000 updates per second. So where do we go from here? Our goal is to actually migrate all of our workloads to Yugabyte Cloud. Our existing self-hosted cluster, we're working with the Yugabyte team now to hopefully move that to Yugabyte Cloud over the next few months. Personally, I'm super excited that follower reads are now in YSQL. We were waiting on that to kind of move some more higher performance applications that need YSQL and would like to use the read replica functionality. We also are looking to use row-level geopartitioning in a few applications. And we want to build our own smart SQL driver for Go, because there doesn't exist one yet. Additionally, we do a lot of our analytical workloads in BigQuery and Looker. So we're looking forward to the upcoming change data capture support or the change data capture improvements that are being made, so we can kind of replicate some of that data to BigQuery. And we already have multiple application migrations that are in progress. And for any of those applications that maybe had unstructured data that don't exactly fit into columns, we're able to use the JSON-B column to kind of store that unstructured data neatly and nicely in Yugabyte. Thank you all so much. Once again, my name is James Hartig, and I'm with Admiral, and I'll stick around for some questions. Thank you.